There's a saying that goes, an architect knows something about everything, and an engineer knows everything about one thing. While I don't agree with the latter part where the saying straight up just throws shade at our engineering brethren, I think the first statement is true, that to be a great architect, we need to know a little bit of something about everything. Be it art, science, or technology. That's why for today's video, we are going to learn how to build our own PC. How's it going, Archi Squad? So nice to see your smiling faces. I hope you all are doing well and sleeping at least 7 hours a day. So lately I've been looking to upgrade my PC and I've been doing a ton of researching as to what best PC specs are available in 2019. And I thought to myself, might as well make a video and share these knowledges that I'm accumulating with the Archi Squad. Cause let's face it guys, as architects of the modern age, we use PCs on a daily basis, and building your own PC is not only more fun than buying an already built PC, it is also cheaper and you get to customize it to better suit your needs or wants. So the first and most important part of a PC is the CPU, or Central Processing Unit. This is like the brains of the PC. A CPU has this so-called cores, ranging from 4 cores up to 64 cores and more. To put things simply, cores are like horses pulling a carriage. The more horses you have, the heavier the weight you can pull. So when looking at CPU specifications, you often see 4 cores at 3.6 GHz base and 4.2 GHz boost. That 3.6 GHz is called the base clock speed, or like how fast each horse can run normally. And the 4.2 GHz boost is how fast the horse can run when you make it drink a ton of Red Bull. So I often just look at the base clock speeds. The higher the base clock speeds, the better. Okay, for SketchUp, Revit, AutoCAD, and ArchiCAD modeling, these softwares often just use 1 core when modeling, so having a higher core clock speed is better. But for rendering with these softwares, they often use multiple cores, so the higher the core count, the better it is when it comes to rendering. So the main goal when buying CPUs is to hit the sweet spot where you have good single core performance and good amount of core counts. My mama once said, there's only so much CPU cores a man really needs. The rest is just for showing off. That was a horrible Forrest Gump impression, guys. I'm sorry for that. Okay, with that awkward Forrest Gump impression, I'll just begin by dividing the CPUs into 4 categories. Category 1 is called Broke Boys, for those with a budget under $200. Second category is called Middle Earthers, for those people who have a budget of $200 to $300. Then we have the rich kids, aka the Gucci Gang. I don't know what that hand gesture was. Anyways, the Gucci Gang is for those who have a budget of $400 to $600. Then we have the Pro category, where you have a budget of $1,000 and upwards. Let's begin with the first category, the Broke Boys. So for the Broke Boys category, I've narrowed it down to 2 of the latest and greatest processors from Intel and AMD. For the Intel processor, we have the Intel i3 8350K at $170. The next processor on our Broke Boys list is from the Team Red, aka AMD. It is the AMD Ryzen 3 1300X processor, priced at $140. So here in the screen, I will show you guys the benchmarks and comparison of these two. You can see that the Intel processor performs better in both overall performance and single core or thread performance, which kinda makes sense because it is more expensive and runs at a faster clock speed. So I don't recommend buying these processors if you are looking into doing some multitasking works and some Revit modeling and rendering. I suggest to save a little bit more money and go for the Middle Earther budget, which is on our next category. So under our Middle Earther category, we have 1 Intel processor and 2 AMD processors. Okay, so I've researched some benchmarks on these 3 and it shows that the AMD Ryzen 7 2700X is the best overall performer due to its number of cores. It has like some crazy number like 8 cores and 16 threads. That's like so plenty, man. But when you look at the single thread performance, the Intel Core i5 9600K is the best out of all these 3. So if you're not into rendering that much and you do a bunch of 2D and 3D modeling, you guys could go for the cheaper i5 9600K. But if you render a ton of 3D scenes, definitely go for the Ryzen. Although it is more expensive, like $30 more expensive, I think it is worth it for the price you pay for the speed. Me personally, I'm an Intel fanboy, but the Ryzen 7 is looking really good. If I were given the choice, I would definitely go for the Ryzen 7 because the more cores, the better. Yeah. Anyways, moving on to our next category, the rich kids aka Gucci Gang. I don't know what I'm saying, man. I'm just trying to sound like those young people nowadays. Under the Gucci Gang category, we have 2 Intel CPUs and 1 AMD CPU. For the Intel side of things, we have the i7-9700K and the i9-9900K processor by Intel. Then on the AMD side, we have the AMD Ryzen Threadripper 1920X. So much numbers with these processors, guys. So by looking at the benchmarks, the i9 is the clear winner in both overall performance and single core performance. Although it is the most expensive at $530 compared to the i7, which is just $420, and the Ryzen at $450, it makes up for its expensiveness with its performance stats. So if you guys are doing a lot of rendering, go for the i9 or the Threadripper, depending on your budget. But if you guys are more into just modeling, go for the i7. But if you guys do both rendering and modeling, I would definitely go for the i9. For me personally, I would probably buy an i9 and maybe sell one of my kidneys to afford it. Because you know, it's so gosh darn expensive. Which brings us to our next category, the professional or the pros category. Under the pro category, I've narrowed it down to 2 CPUs. But there are definitely a lot of choices out there that are super crazy expensive, as in never afford it even if I hit the lottery 5 times type of expensive. Anyways, here are the processors that are both priced at around $1,800. So for the Intel side, we have the Xeon Gold 6126. And for the AMD, we have the Ryzen Threadripper 2990WX. If we take a look at the benchmarks, we could see that the Threadripper is a bit better at both the overall benchmark and the single thread benchmark. So it's a no-brainer which of these two you should pick. Now keep in mind that the motherboard compatibility of these two processors are a bit weird and uncommon. Most stores don't even carry motherboards with STR4 sockets or LGA 3647 whatever socket. So before purchasing these processors, make sure that their motherboards are available and are within your budget. And that about wraps up how to choose a processor for your computer system. Anyways, let's move on to my personal favorite, the graphics cards. Graphics cards are super important, especially if your 3D model has a lot of polygons. Basically, graphics cards are what process what we see on our screen. So if you are having issues with the screen lagging every time you rotate or zoom in on your 3D model, it's probably time to buy a new graphics card. Also, if you're a gamer/architect and want to play the latest games in ultra settings, then graphics cards are super important for you. So aside from games and 3D modeling, programs like Adobe Photoshop, Lightroom, After Effects, and Premiere Pro benefit from CUDA acceleration, which basically means it increases your computing performance by using your graphics card. And also now, a lot of rendering softwares take advantage of the GPU's rendering power to make render times 5 to 10 times faster than if you render it with your CPU. So some of these softwares are namely V-Ray, Lightworks, Thea Render, Maxwell, Mental Ray, Octane Render, Furryball, and Arion, to name a few of the programs that use GPU for rendering. Okay, so for this part, we will just be looking at Team Green graphics cards. And when I say Team Green, I mean NVIDIA graphics cards. Because right now, I think the NVIDIA cards have the advantage of having CUDA acceleration while performing decent numbers on OpenCL applications. By the way, CUDA and OpenCL are software frameworks that allow GPUs to accelerate processing in applications that support them. So NVIDIA has CUDA and then AMD has OpenCL. So for the graphics cards, I'm going to start from the cheapest all the way to the most expensive one. But before we do that, let me just explain the specs of a graphics card real quick. So as an example, let's look at the cheapest one on our list, the GTX 1070. So as you guys can see on this list, the GTX 1070 has 1920 CUDA cores. So you guys know that saying less is more. This is not true when buying computer parts. When choosing computer hardware, always remember more is more. That probably made no sense. Anyways, the more cores, the better it is. Below that, we can see the base clock and boost clock. So just like the CPUs, the higher the boost and base clock, the better. Okay, under that, we have memory configuration, where it says 8GB GDDR5. 8GB stands for how much VRAM it has, and GDDR5 is the memory rate. Now, I'm gonna flash a list on the screen. So starting from right to left, we have the GTX 1070 at around $350 at the time of recording. Then we have the GTX 1080 at around $550, and so on and so forth. You guys could just pause right here and check out the specs or take a screenshot. Okay, now I'm going to show you guys a benchmark of how well these GPUs fare when compared to one another. So in this benchmark, the shorter the red bar, the better, because it means that it took the GPU less time to render a specific scene. So as you guys could see, the NVIDIA RTX 2080 Ti is the fastest among our list, even beating the Pro GPU NVIDIA Quadro P6000, which costs 4 times as much as the RTX 2080 Ti at a butt clench inducing price of $4,700. Damn, this is expensive, man. You could probably buy a house and a ton of flip-flops with that kind of money. Anyways, with this benchmark, you guys could see that the RTX 2070 did almost as good as the NVIDIA Quadro card, and it only cost $600. So for me, I think I will either go for an NVIDIA RTX 2070 or a 2080. Although the performance increase is very small for a $200 price difference, I think the 2080 is a bit more future-proof than the RTX 2070. Okay, we're almost done, guys. On to the next PC component, which is the RAM. So RAM stands for Random Access Memory. It's where your PC stores data so you could access it faster. So as an analogy for this, imagine RAM as table space. So when you're drafting, the more table space that you have, the more things you can put on top of your table. Things like your pens, some markers, triangles, and maybe some snacks over here. So instead of keeping all of these things in your bag, which takes time to take things in and out of, you can just place it in your table and randomly access your items immediately. So to make things simple, a good rule of thumb is 1 GB of RAM per CPU core. So if you are planning to buy a 16-core CPU, you are going to need 16 GB of RAM. But that is assuming that you don't have any Google Chrome tabs open. If you're into multitasking, like having a few Chrome tabs open, Photoshop is running in the background, you have AutoCAD and Revit open, and then for some reason you're like running an antivirus scan while modeling in SketchUp, then I suggest getting 2 GB of RAM per core. Alright, on to our next item, which is the storage drives. Remember my analogy of RAM a while ago? So if RAM is your drafting table, then storage drives is your bag where you keep important stuff that you don't need to use frequently. So there are 2 types of storage drives. You have your SSD or solid state drives, then you have your HDD or hard disk drives. Solid state drives are faster and smaller than HDDs but are more expensive. So with that being said, which of the 2 do we need to put inside our PCs? The answer is both. For SSDs, we are going to need a minimum of 250 GB. So this is where we will store our PC's operating software and all of our architectural programs. So the advantage of using SSDs to store your OS and programs in is that booting up your PC takes less time, as well as opening your architectural programs like CAD and Revit. Okay, so now that we have chosen our SSD, it is now time to get our HDD. So for your HDDs, you will need at least 1 TB of storage. A good brand of hard disk drives is Western Digital. I usually like to buy WD Blues because they are cheaper. But if you want good performance and don't mind the price, go for Western Digital's Red HDDs. Okay, we are now on the second to the last item on our list, and holy moly did this video take so long. Probably spent 2 hours recording this video already. Anyways, the next item on our PC hardware buying list is the PSU or Power Supply Unit. So I find this to be the most boring part of a PC, so I'll just keep it real simple and fast. But without this thing, your PC won't even turn on, so I'm guessing it's a pretty important part of your PC. Okay, so when looking for a power supply, it is important that you get the wattage correct, or else you could end up frying your computer like a burnt chalupa or something like that. Something barbecue related. Insert barbecue joke here. It's pretty late, guys. I don't have time to come up with barbecue jokes. Anyways, to calculate the wattage, there are many great websites on the interwebs that help, like this one by Cooler Master. All you have to do is input your PC hardwares, so make sure to input any future hardware upgrade. For example, you are planning to get an extra HDD, just put that in, then place how many hours per day you will use your PC. Once that's done, click on Calculate. So once the website is done calculating all this stuff, it is going to give you your recommended PSU wattage and also recommend a product suitable for your needs. Last but not the least, now that we have all our items down, we now have to choose our motherboard. Now, when choosing a motherboard, all you have to keep in mind is the CPU that you bought. Is it compatible with the motherboard? Meaning, is the CPU socket the same as the motherboard socket? Then you have to check if it could support your graphics card GDDR5s. All recent motherboards support DDR4 memory and GDDR5 graphics cards, so as long as you stick to the latest motherboards, there's no need to worry. Now, all you need to worry about is how will your motherboard look in conjunction with your graphics cards. So the gamer in me suggests that you guys go look at some Asus gaming motherboards, but the architect and professional in me tells me to go for WS workstation grade motherboards. The main difference between the two just basically boils down to the target audience. The gaming motherboards looks cooler and are more gamery. Is that a word, gamery? While the WS workstation boards look more boring and have more features geared towards professionals like Xeon processor support, but I personally just like gaming motherboards. And with that being said, I guess those are the main PC components that you have to carefully look at and think about when building your own PC for architecture and design purposes. So I know I skipped some parts like fans, cooling units, and cases, but all of that just boils down to personal preference and your budget. Anyways, with that being said, I hope you guys learned something new today. If you did, please like, comment, and subscribe, and maybe hit that notification bell down below and be a part of the Arky Squad notification riders. I need to come up with a better, less corny squad name than Arky Squad Riders. I can't even remember it, guys. Gosh dang it. Anyways, thank you guys for watching, and thank you so much for supporting my channel. We are now at 51,000 subscribers and counting. So awesome, man. Anyways, I'll see you guys on my next video. Arky Squad represent. Flying peace!